Hello everyone. Let's solve today's daily Leetcode problem 3202. Find the maximum length of valid subsequence part 2. This is a continuation of yesterday's part 1 problem. Before going through the problem and figuring out a solution, let us look at a motivational quote. Always remember, everything is hard at the first try, whether it's learning a new skill, starting a new job, or facing a new challenge. The beginning is always the toughest. With patience, practice, and persistence, what feels difficult now will soon become easier. Don't give up, keep going, and you will see progress. Stay motivated. Okay, so I wanted to specifically say everything on the first try will be an hard thing, right? And it is no different for anybody on the planet. So just get used to it and just try working hard on the first try so that you would figure out a solution later, and with solving a difficult problem it would give you a lot more motivation to solve others as well. Okay, so now let's think about how we can solve this problem. You are given an integer array nums and a positive integer k. A subsequence sub of nums with length x is called valid if it satisfies sub 0 plus sub 1 modulus of k is equals to sub 1 plus sub 2 modulus of k, and so on. Return the length of longest valid subsequence of numbers. Okay, similar to yesterday's, there is a parameter k. In the yesterday's problem, we were just modding it by 2 and returning the longest possible subsequence. And this was the same example if I remember it right. So we were not given with this k explicitly, but we were asked to mod it by 2. But here we have given k with 2. So all of these are a possible subsequence. Okay, so let's look at example 2. In example 2, we see nums k is equals to 3, where let's say if we mod these to 1 plus 4, this would give us 2, 3 plus 2, or 4 plus 2, 6. 6 will be 0, and 2 plus 3, 5, which will be 2. So 3 plus 1, which will be 4, and 1 plus 4, which will again give us a 2. So I see one pattern. So if we take this as a possible subsequence, this till the circular part of this array where 1 4 1 4, then this becomes a valid subsequence of length 4, right? Okay, so like I said, similar to yesterday, the only difference that we are looking here is with respect to modding it by k. Uh, in part 1, we had been given with 2 and we were creating a DP array of 0 0 or 0 1 1 0 1 1. This was our DP array, right? Similarly, here we might need to create DP array of k times and k times. So, yeah. Uh, so let me start having a dry run on the way that we are looking to solve this problem, and from there I think our solution, the way that we look to code, should become more clear for us to solve, right? So the way that I'm going to do here is, so I am going to create a DP array such that we have k set of reminders, that is 0 to k, 0 to k arrays, and I am going to fill each each array with 0. So 0 to uh, k filled with zeros. And now I'm going to look at each nums nums array, and I'm going to check mod of the specific num by k, or this would give me a mod value of the current number, and I'm going to say position is equals to a j variable which 0 to k. So position minus j mod k plus k, and let's see what this mod gives us. So this is more like uh, we are checking the previous we are checking if uh, we can create an extension from the previous number, and we are storing it in a dp array with tracking it with all the possible reminders, and we append this to the dp mod of the current number with dp mod of position plus 1, right? So if, let's say, and of course we definitely need to track the result with math.max result or the dp array, or the maximum value in the dp array, right? So I am going to take an example of nums, let's say 2, 5, 8 with 11, and k is equals to 3. So as I said, k, we are going to have a j pointer looping through k, that is 0 to 2, and each time we create a dp array, uh, for each value of k we create a dp array, say 3 number of times as we iterate, and for each num we check the mod of the specific num, and we also check if position j minus mod plus the number k. uh, so j is the current mod. uh, if it's a possible position to extend, then we say dp of current mod plus 1. So the way that we are looking at is, so let's say if j is equals to 0, we create a dp array of uh, 3 values in the dp array, and we loop over the nums. The first value in the nums is, let's say, 2, 2, and we we know that the position value will be 0 minus 2, 2 plus k. K is 0, mod of mod of 3. This should give us 2. So dp of position 2, the position value is 2. So the dp of mod that we are looking to add to the dp array will be dp of position, which initially will be assigned with 0 plus 1. So this is the new value. And at each point we calculate the result with max. So that's another thing. And for each num. So this is the first item in the num. So the next value is 5. With 5, we do the same thing. Say we calculate position, which was uh, 5 mod dp of j, which was 0, and it would be 0 minus 0 minus 2. This is the mod of number per 5 plus k. K is equals to 0. So this again gives us a value of 2. dp of current mod will be so we can have a possible subsequence with these two values. That's what this means. And let's say once we go to 8, similarly we calculate dp mod. I am just skipping steps here, but yeah, our formula will be like dp mod dp of position plus 1. So this position value will be j minus mod plus k modulus of k, right? So this will be j is equals to 0, mod of the current number 8 will be 2, and k is equals to 0, right? So this will give us 2, and this will be another possible pair, and we can form pair tilt here. The same goes here. So this will be 3. So, and at the next iteration it becomes 4. So at k is equals to 0, we would have already seen dp mod taking up value of 4 at position 2. dp of position 2, that it will be taking up 4, and that's the output for this problem. I i have skipped through many steps, but I would like to hear if you feel any of these looks little strange or little different. Let me know in the comment section. I would i would be more happy to explain or add comments to your questions, right? So with this, I will be translating the same that we had here, these set of problems and these set of while loops, to the lead code, and let me try solving this. So now I would start coding this solution up. Okay, so I've completed the solution part here, and I am submitting the solution. In the meantime, time and space complexity of the solution is of n into k, where there are two for loops where I'm iterating through each nums, and also k is the reminder or the parameter that is being sent as an argument here. So n times k is the time complexity. Space complexity would be O of k, right? So we are creating a DP array with k, and every time we are having to check the math.max of it. Okay, so one thing that I would at least take away from this problem is from uh, from the previous part one, we were only required to think about how a continuous subarray could be built with modulus of 2, but here there is a variable k which uh, acts as a acts as a acts as a acts more as a complexity to this part 2 problem. So we are tracking all the possible reminder values that each num gives out, and we are increasing the specific index at the DP array, and then also calculating the maximum value. So I hope uh, we could learn something from this problem, and we could we can now get a rough intuition on how we can uh, expand our knowledge, where, let's say, if we are asked to take a modulus of a single parameter and find a subarray, so we could solve it in certain uh, way, where we store a deep where we can store it in a DP array of 2 comma 2 DP array, which was for a specific or a constant mod. In case of a variable which we are required to dynamically mod, then we need to have a k cross k DP array, but here we are just using a DP array and just having to calculate math.max. But yeah, just let me know in the comment section what your thoughts around this problem is. I would be happy to hear your thoughts and intuition in the comment section. Hope you found this video helpful. Until then, take care. Thank you.